Now let's see about the another very interesting and crucial topic of using the dropouts and batch normalization, right? So like why we are actually using the dropouts and batch normalization in the middle of hidden layer is that to avoid the risk of overfitting and to make the process more smooth and more static, okay, or to make the neural network conversions more faster, right? So when it comes to dropout, now what happens in a dropout is that whatever the neural network that you have, right? So when it comes to overfitting, it means that it is actually like gathering all set of data points, okay, which we don't want, okay. So what we actually needed and what is very crucial is that why not we just deactivate some of those neurons, okay, so that the information that it is feeding to the next hidden layer, okay, it is not the complete full information, it's the some percentage of the information. And why we are actually intending to do it, because we don't want to overfit the data, that's why. So in order to understand a dropout, we can actually like handle the dropout to so the risk of overfitting. So in order to like handle that point, so you need to like use the dropout in the middle of the layer, okay. So there are two way of looking at the dropout, like the regularization. The first way is that using the regularization, okay. So there are two ways to look the overfitting. The first way is that you can either reduce it using the regularization term, where you have a L1, you have a L2, okay. Then you have a ridge, which is like the combination of the L1 and L2. Elastic net, right, which is a combination of L1 and L2. There is a lasso, there is a ridge regression and other things. You can actually like use it into the regularization term. The other thing which is like most commonly practiced when it comes to deep learning in neural network, in the middle of the hidden layer, is that you use the dropout, okay. So what is dropout? The name suggests that whatever the inputs layer, that whatever the inputs you have, right, so this is basically your first layer, okay, and these are basically the hidden layer, right. So you basically deactivate some of those hidden layer neurons, okay. There is something called as percentage ratio or part to percentage ratio. Let's say that if I keep the probability as 0.6, it means that I want to like deactivate the 60% of the neuron, okay. So if I just in the hidden layer 2, if I just put the dropout ratio as 0.3, it means that I want to deactivate it 30% of the neurons, okay. And always make sure that you don't do dropout at the very early stage of the input layer, okay. Why? Because you really don't want to like manipulate your input layer, okay. Because if the input itself is like giving it to the hidden layer, okay. If you're actually like masking the input itself, then it is not a very healthy practices, because you are making this model to forget your information at the very first layer, which you don't want, okay. The purpose of using the dropout is to reduce the overfitting, right. Not with the intention that you should always like use the dropout at the very early layer so that your data itself is getting compromised. That is why, right. So I hope you get it from the dropout, right. So why we are actually using the dropout, so that we can actually like reduce, or we can actually like switch off some of those neurons, okay, in the hidden layer, so that it will not overfit, okay, so that it can actually take your data and like proceed it in a more manual and smoother way, right. Now the other thing which is like which is very common is batch normalization, right. So the batch normalization, what does that mean is that but before like please understand, please try to understand that batch normalization, that most of the people confuses that the batch normalization normalizes the weight before giving it to the new layer, okay. It does not normalize the weight, okay. It actually normalizes the activation function, okay. The things here actually like giving it to the activation function. I told you earlier, right. So every neuron will be having some kind of a summation, some bias, and some activation function, okay. So whatever the weights that you're that this neuron is getting, okay, batch normalization does not like normalize this weight, okay, after the activation function and before giving it to the next neuron, okay. It actually normalizes the set of activation function results that you have, okay. So this should be the flow, okay, that this is actually your input, this is actually your input, this is your layer, hidden layer, which means that which is your linear layer, and this is your, we are actually supposed to do the batch normalization, okay, over this summation part, and then you are supposed to give it into activation function, and then it will proceed to the next layer, okay. I hope you get the flow. So batch normalization, like in the modern scenario, so if you really wanted to interested in this equation, you can actually like understand that this is actually the mean, this is actually the normalization formula, okay, and this is like the scaling factor, right. So where like the gamma and beta are like the trainable parameters. So whenever you're actually like training into the backward back propagation, so you can actually like try to train this parameter as well, so that next time it does the normalization more perfectly, okay. So that all the parameter actually align towards the mean, okay. And then let's say that it has a very good standard deviation, okay. That's fine. So again, the modern days alternative of batch normalization. So in most of the times we go for this batch normalization, but these days I think the many researchers are actually using the layer normalization, group normalization. You can try it by yourself and like see the result, that how is going to impact your result, right? then the evo normalization, the instance, and then the like the synchronous batch normalization. So you can actually try it out. Okay, and don't worry, like these things are actually like it's very common term to use. Okay, and you can actually like use the batch normalization from the TensorFlow library as well, right? So from TensorFlow Keras, if you go with the sequential, you can actually like other than like making the neural network, you can actually attach the dropouts in the middle and in the batch normalization. Okay, so these things are already supposed to be present in the pre-built library, so you don't need to write a very complex equations. Just understand the concept of the dropout and the batch normalization. Okay, so why batch normalization? Because we wanted to so in the neural network, you wanted to like make your flow convergence flow more effectively. That is why you're supposed to use the batch normalization. And why dropouts? Because you wanted to reduce the failure of overfitting. Okay, so it has a two-way. Either you go with the regularization term, either you use the dropout term, or you can actually go with both. Okay, so these things just keep in mind the dropouts and the batch normalization. That's it. Thank you.